Today we will see how to evaluate the integral x raised to the fourth power times e to the 3x dx. Of course, this is a question where we must repeatedly use integrations by parts. Today I'm going to show you a method which will save plenty of your time when we use same integrations by parts but in an effective way. Of course, this method is a well-known method and many people already practice this method. Please make sure that you also know this method. Alright, as with any other integrations by parts question, we need to first identify a function u and a function dv. For this question, we know that x raised to the fourth power should be identified as the function u and e to the 3x should be identified as the function dv. If you look at integrations by parts, the equation is integral u dv is equal to uv minus integral v du. Remember that the first term is positive and there's a negative symbol associated with the second term. Alright, now we are going to straight away start the solution procedure. I'm going to write u as given. U is equal to x to the fourth power. And then I need to write dv, but I will not write dv as the same level as u. Instead, dv will be written on the line above. dv is equal to e raised to the 3x. dv should be integrated in order to obtain v. v will be equal to e to the 3x divided by 3. Alright, next the fun part begins. We need to keep differentiating the function u, and we will need to keep integrating the function v. But how many times do we have to differentiate u and how many times do we have to integrate v? Well, here's the guideline. We keep differentiating the function u until it becomes a constant, and the number of times that we need to integrate v is equal to the number of times that you differentiated the function u. Alright, let's start differentiating u. Let me write the first derivative of u as u superscript 1. That will be equal to 4x cubed, which is not a constant. Therefore, I need to differentiate u again, which I will write as u superscript 2. It will be equal to 12x squared. Even that's not a constant, which means I need to keep going. I will find the third derivative of u, which will be equal to 24x. Even that's not a constant. Therefore, I need to differentiate it again, which is going to be the fourth derivative of u. It will be equal to 24. Alright, I have differentiated the function u 4 times, which means I need to integrate function v also 4 times. Let me integrate v for the first time. Let me write it as v sub 1. It will be equal to e to the 3x divided by 3 times 3, which is a 9. And I need to integrate v for the second time. Let me write it as v sub 2. It will be equal to e to the 3x divided by 3 times 9, which is 27. We need to integrate v for the third time. Let me write it as v sub 3. It will be equal to e to the 3x divided by 3 times 27, which is 81. And we have to integrate it one more time. It will give me v sub 4. That will be equal to e to the 3x divided by 3 times 81, which is 243. Alright, next, remember, I will have to multiply the corresponding u's and the v's. u times v will be multiplied straight across. And then the first derivative of u will be multiplied by the first integral of v straight across. Once those two are multiplied, then we will look at the second derivative of u and the second integral of v. Those two should also be multiplied straight across. And then u3 and v3 will be multiplied. And then u4 and v4 will be multiplied. But there's one more. That is, if you go back and look at integrations by parts formula, look at this. The first term is positive, the second term is negative. And we will see this pattern being repeated even in this method. The first term will be positive, and then you will need a negative symbol for the second product. and then you will need a positive symbol, and then you will need a negative symbol and a positive symbol. Likewise, for how many terms you have, you need to keep flipping the symbol starting from plus and then minus, then plus, minus, plus, minus, and so on. Alright, now we are all set. We can write down the final answer. Our question was integration x raised to the 4th power e to the 3x dx. Our final answer will be equal to, first product is positive, u times v. It will be therefore x to the 4th times e to the 3x all divided by 3. The next term is negative. Let me write a negative symbol, and then I need to write 4x cubed times e to the 3x over 9. The next term is positive. Let me write a positive symbol. I need to multiply 12x squared and e to the 3x over 27. The next term is negative. I'm going to write a negative symbol in the next line since I'm running out of space, and then I have 24x times e to the 3x divided by 81. The next symbol is positive. Let me write the positive symbol. That will be 24 times e to the 3x divided by 243. And this is an indefinite integral. That means in addition to all of these, there will be a plus c. Well, this is also not the final answer. That is because we can simplify it some more. We can see that 12 and 27 have a common factor, which is 3. 12 divided by 3 is a 4. 27 divided by 3 is 9. In the next fraction also we have a common factor, which is 3. 24 divided by 3 is 8. 81 divided by 3 is 27. And again, right here also I have a common factor. Once again, 3 is common. 24 divided by 3 is 8. 243 divided by 8 is 81. Alright, now we can go ahead and write down our final answer. X to the 4th e to the 3x over 3 minus 4x cubed e to the 3x over 9 plus 4x squared e to the 3x over 9 minus 8x e to the 3x over 27 plus 8 e to the 3x over 81, and we have a plus c. That's the final answer for this question. If you would like to try this method and do a homework question, I would like to give you one. Alright, here's my homework question. Integrate x raised to the 5th power sine 2x dx. Using the method discussed in the video, you can get the answer fairly quickly. Alright, I hope you enjoyed this video. Thank you so much.